Problem number 1. In the number 2010 or 2010, the value represented by the digit 1 is what fraction of the value represented by the digit 2? So we have the number 2010, or we could rewrite this as 2000 plus 0 hundreds plus 10 plus 0. And they're saying the value represented by the digit 1, well, the value represented by the digit 1 is 10, is what fraction of the value represented by the digit 2? Well, the digit 2 represents 2000. So the fraction is going to be the 10 divided by what the 2 represents, 2000. The 1 represents 10, the 2 represents 2000. You get, let's see, we can cancel out a 0 right there. We get 1 over 200, which is choice B. Problem 2. If p is a positive integer, which of the following must also be a positive integer? Let's see. Choice A, 1 minus p. Well, if p was 2, 2 is a positive integer, then 1 minus 2 would be equal to minus 1. And this is not a positive integer. This is a negative integer. So it can't be A. 1 over p. Well, once again, I'm just picking 2 at random. It's a positive integer. If p is 2, then 1 over 2 is not a positive integer, so it can't be b. Let me cross that out. Cross that out right there. Well, I'm just going to keep running with my number 2. If it doesn't work for number 2, it's definitely not going to work for any positive integer. So if p is 2 right here, then the square root of 2, once again, not a positive integer. And then finally, p squared. Well, for 2, if I say p is equal to 2, then p squared is equal to 4. And in general, if I take any positive integer and I square it, if I multiply it by itself, I'm just going to get another. It's definitely going to be positive, and it's definitely going to be an integer. So my choice is D. Next problem. Problem 3. Let me switch colors just for fun. According to an article in a financial journal, a certain company earned 3.85. Why isn't it writing? Oh, I haven't selected that late. Earned $3.85 million last year. Based on this report of the company's yearly earnings, a person reading the article estimates that the company earned an average of approximately $30,000 a month. And they're saying estimates, so we don't have to do the exact math. Which of the following statements best describes the reasonableness of this estimate for the company's average monthly earnings? So $3.85 million last year, and we want to be able to estimate how many monthly earnings. So we want to divide 3.85 million by 12 months, right? That's 3.85 million a year, and we want to divide it by 12. We could do the exact number, but we could say, hey, you know what? This is pretty close to 3.6 million. The reason why I'm picking 3.6 million is because 36 is 3 times 12. So if we do 3.6 million, we could say that this is approximately 3.6 million divided by 12, which is equal to what? If this was 36 million divided by 12, we would have 3 million, right? But it's not 36 million divided by 12. It's 1/10 of that. It's 3.6 million divided by 12. So it would be 0.3. 0.3, and you can put a 0 out front, 0.3 million per month. Or another way to write 0.3 million is 300,000 per month. Now, someone estimated that they made $30,000 per month. So they were off. They were too low by a factor of 10, right? You would have to divide by the actual estimate, the correct estimate, by 10 to get their estimate. So their estimate is too low by a factor of 10. That is choice B. Another way you could have thought about this is instead of writing 3.85 million, you could have written that as 3,850,000 divided by 12. Or you could have said, well, that's approximately 3,600,000 divided by 12. And then you said, okay, that's 300,000. You would have gotten the same answer, which is 10 times more than their estimate, or their estimate was too low by a factor of 10. Problem 4. The mean distance from the Earth to the Sun is approximately 93 million miles, or 1 astronomical unit. The mean distance from Neptune to the Sun is approximately 2.794 times 10 to the ninth miles. What is the approximate mean distance from Neptune to the Sun in astronomical units? So essentially, we want to divide the average distance of Neptune, 2.794 times 10 to the ninth miles, divided by one astronomical unit, which is 93 million. When you write it like this, it's kind of hard to digest or see what's going on, but what we can do is write this guy right here in scientific notation as well. So 93 million looks like that. We could say that this is 9.3 times 10 to the 1, 2, 3, 4, 5, 6, 7th power. So now this thing up here simplifies to 2.794 times 10 to the ninth over 9.3 times 10 to the seventh. Now, we could just divide this, but the way my brain works, I would like, instead of this to be 2.7, I would like this to be 27. And the reason why I would like this to be 27 is because we have a 9 down here. And then we could say, hey, 27 divided by 9 is roughly equal to 3. So we could rewrite the top part of this. We could rewrite this. If we multiply this part by 10, we would have to divide this part by 10 in order to not change the number. We don't want to actually change the value of the number. So we get 27.94 times 10 to the 8th. Right? All I did is I multiplied this part by 10, and to offset that, I divided this part by 10. 10 to the 9th divided by 10 is 10 to the 8th, divided by 9.3 times 10 to the 7th. And now you could say, look, 27.94 divided by 9.3, that's going to be approximately 3. Remember, we're trying to find the approximate mean distance. We can estimate a little bit. And then 10 to the 8th divided by 10 to the 7th, you could just subtract 7 from 8 on the exponents. And so that's times 10 to the 1. 10 to the 8th divided by 10 to the 7th is exactly 10 times 10 to the 7th. So our approximate answer is going to be 3 times 10 to the 1, or 3 times 10, or approximately equal to 30 astronomical units. And that is choice A.